A VPS is a rented virtual server that stays online on the internet. You control it remotely, much like a computer. Your laptop can be off, but the VPS keeps serving your site. A browser reaches Caddy over HTTPS. Caddy forwards the request to FastAPI, and FastAPI uses a private PostgreSQL database. Before you connect, create an SSH key on your own computer. This command creates a private key and a public key. Keep the private key on your computer. Next, display the public key. Copy that one line into your VPS provider's SSH key field. Never share id_ed25519. Only share id_ed25519.pub. Connect with the initial username from your VPS provider and verify the server fingerprint. On the VPS, create a new user named deploy and grant it sudo access. Sudo lets that user run an approved administration command when needed. Give deploy its own SSH folder. Now, on your own computer, copy the full public key line from id_ed25519.pub. On the VPS, create the empty authorized _keys file for deploy. Open it with sudo edit and paste that one public key line. Never copy is_ed25519. That private key stays on your computer. Keep this session open. In a new terminal, sign in as deploy and run sudo womi. Once that works, disable root and password logins, test the SSH configuration, and reload SSH. Start by updating Ubuntu. apt-update refreshes the list of available packages. apt-upgrade installs the available updates. Next, install the building blocks: Python virtual environment tools, PostgreSQL, Caddy, the UFW firewall, and a few network utilities. These commands use sudo because they change software for the whole server. Finally, run the checks. You should see a Python version, then active twice, once for Postgres and once for Caddy. The exact Python number may be different. The important word is active. First, test the release on your own computer. Then build the deploy package from the project root. The package contains code and dependency files, but never your .env file, virtual environment, logs, or secrets. Copy the completed package to the VPS temporary folder. Replace the example file name with the name your build created. Finally, check that the archive arrived. Its name and size should appear. Use that same name in the next commands. Create a system user named AppUser. It cannot sign in through SSH. It runs the application without administrator permissions. Create app for application code owned by AppUser. Create etc. app for configuration and secrets, owned by root and readable by the app group. Now extract the package as AppUser and list the files. Check that requirements-prod.txt is present in opt-app. App code and secrets stay separate. Create the database user for the application. This command asks for a password. Do not show or record that password. Next, create the application database and make AppUser its owner. Then list the database to confirm it exists. The database stays private on this VPS. PostgreSQL port 5432 is not opened to the firewall or the internet. Create the environment, file in etc. app. Root owns it. AppUser can read it but cannot modify it. Open it with sudo edit. In the video, show only variable names such as database URL and admin token. Never show their values. Keep every secret on the VPS, not in the project folder. Next, create a virtual environment as AppUser. Upgrade pip, and install the production requirements. Finally, check the Python version inside the virtual environment. Do not leave the application running in a terminal. Systemd starts it when the server boots and can restart it after a failure. Create the service file. It runs as AppUser, reads the environment from etc. app, and binds FastAPI only to localhost. Reload systemd, enable the service, and start it now. Check that the status is active and running. Then, call the local health endpoint. If something fails, read the service journal before changing anything. A domain is usually a paid service. You can often buy it and manage its DNS records through the same domain registrar. Create an A record for the root domain and point it to your VPS public IPv4 address. If you want www, Create a CNAME alias that points to the root domain. Do not create a CNAME on the same name as an A record. Skip quadruple A unless your VPS has working IPv6. Finally, use dig to confirm that the domain resolves to your VPS. DNS changes can take minutes or hours to propagate. First, check your VPS provider's firewall. Allow SSH, HTTP on port 80 and HTTPS on port 443. Then configure UFW on the VPS too. Set the default policy to deny incoming traffic and allow outgoing traffic. Before enabling UFW, allow Open SSH. That keeps your current SSH connection safe. Open only ports 80 and 443 for the web. Then enable UFW and check the numbered status. The final list should contain SSH 80 and 443 only. Do not add PostgreSQL port 5432. The database stays private. A Caddy file tells Caddy which domain to serve and where to send each request. When DNS works and ports 80 and 443 are open, Caddy can automatically obtain and renew an HTTPS certificate. That certificate proves control of the domain and encrypts traffic between the browser and Caddy. Caddy then forwards requests to FastAPI on the local address only, so the application is not directly exposed to the internet. Redirect www to the main domain, enable compression, and use reverse proxy for the local application. Caddy also forwards WebSocket connections automatically. Validate the configuration, start Caddy, and check that the service is active. If the certificate does not arrive, check DNS, both firewalls, and the Caddy logs. Now verify the public site from your own computer or from the VPS. Use curl with HTTPS to inspect the response headers, then call the health endpoint. Both checks should succeed over the public domain. Open the site in a browser too. Check the padlock, the main domain, the www redirect, the map or main feature, WebSocket behavior, and the mobile layout. These are the essential checks for a first deployment. You can add automated project tests later, after you understand what your application needs to verify. A deployment is ready when the public checks all succeed. A backup is useful only if you can restore it. First, create a protected backup directory and use pg_dump to create a Postgres dump in the custom format. Use pg_restore with the list option to confirm that the dump can be read. This does not restore any data. Copy backups regularly to encrypted storage outside the VPS. A backup stored only on the same server is lost if that server is lost. Practice a restore in a separate test database. Replace the date placeholder with the real backup file name. Restore the dump there. Confirm that it works, then remove the test database. Never practice a restore against the production database. For the next release, do not rebuild the server. Deployment follows the same two-terminal path every time. In your local terminal, run your local checks, build the package, and copy it to the VPS with SCP. In a second terminal, connected to the VPS with SSH, unpack the package as the application user, install any changed dependencies, restart the service, and check the public health endpoint. This is a repeatable manual path. Later, you can automate parts that you understand. A VPS is not only a place for code. A safe deployment is a repeatable sequence. Connect securely, isolate the app, keep the database private, serve HTTPS, verify, and back up.